So let us start coding in Kaggle. I'm in this Kaggle platform, and I'm just going to create one new notebook using this plus icon, and let us start coding. So let me name this as simple linear regression. So the first and foremost is we import all the libraries. So here I am importing NumPy as NP because linear regression, mostly our data format has to be in arrays. So we need NumPy. Then for all our transformations, import pandas as PD. For visualization, import matplotlib dot pyplot as plt. Import seaborn as sns, and from sklearn dot model selection, import train test split, and then I'll import statsmodel dot api as sm, and this is the main um, library that we will be using for linear regression. Then from sklearn dot metrics, import mean absolute error, and also import warnings, and I'll filter the warnings, filter warnings. I'll just ignore to just get rid of the warning messages. I'll press this run button here. This is taking some time. So we have got some error. Okay, so it is statmodels.api. Now let me run it. And now it is completely running. So the most important thing is we need some data here, right? So you can see in the right hand side, you have this add data. You press this add data and you can search for salary data. And this is where in the recent searches, I'm seeing this data. So I'll just simply add this data set to my analysis. And then now this workbook is having this data, and let me see the path of this data. If you just expand it, then you see the csv file, right? So we need this path to read this data set. So I'll just copy the path and I will read underscore csv, and just do this, and I'll give this a name as data. And then I'll just click enter, and now my data set is saved. So just a quick inspection of the data set, data.head. Okay, so you can see we have only two variables, years of experience and then salary. So let us do some exploratory data analysis where we just see we just do a describe, and we get all these metrics, how many entries are there, what is the mean value, what is the standard deviation, um, what are the percentiles. So obviously we can see that there is not huge outliers in the data set. uh, the because the 75th and the maximum are not very far from each other, so we don't have a lot of outliers, and this looks good. And obviously there we'll check data.info. Okay, so there is no null values, everything, the data set looks good. So now we will check the assumptions, that whether the two variables are having some relationship or not. So the way we can do it is we can plot them in x and y and see if we see the trend. So let us plot using a scatter plot. So for that I'll use plt dot scatter. So on the x-axis will be my independent variable, which is years of experience. Let me do one thing is get me the name, column names. That way I can paste it. Okay, so PLT scatter on the x-axis, and on the y-axis I have salary. Okay, so I'm doing a scatter plot. So let us see. Okay, so this is what we see is we see a very straight line. This shows that there is linear relationship, and we definitely want this assumption checked when we are applying linear regression. So let us make this plot more readable. So on the x and y axis, let us label. So we will add plt dot x label. X label is years of experience, and on y label we have salary. Okay, and you can also give a title as well, but I'm just going to leave that for now. So this is the direction of the relationship. You can also check the strength of the relationship by doing a data.core. Okay, so you see the correlation coefficient is 0.97. That's very high. Okay, that is good. So because the data set is good, now let us apply the machine learning model. Before applying it, we need to split the data into train and test. So for that, we need to isolate the x and y. So what will be my x and what will be my y? So obviously my x is data and years of experience. Okay, and my y is data and salary. Okay, but obviously we need to convert them in a matrix or array format. So I'll just add values to it. Okay, so this is what it is. So now if you look at x like this, we see this, it is an array format, and y, this is also in array format. So all of them should be in array format. So after having converted them in the array format, let us do the train test split. So we will x train, x test, y train, y test is equal to train test split. And then here we give our x and y variables, and we also give test size. We can keep it 0.2. This means that 80% of the data set will be used for training, and then 20% will be used for testing. And then for reproducibility of our results, we specify the random state as 100. Yeah, just click enter. So now we have our X train, X test, Y train, and Y test. So now we can apply our models. So before uh, proceeding with the model, we need to understand that usually when we see the linear regression line as y is equal to a plus bx, so there is some constant to it, right? So to the x we need to add constant. So how do we add it? Is we use the stats model sm dot add constant, and this is my x train. So this is my x train with intercept. Okay, and then what we'll do is we will use the stats model. We will use the OLS, ordinary least squares, and whatever is my y train, on that I will use my x as x train, and then I'm going to fit this into a model, and I'll rename this as model. Okay, so now let us look at model summary. So here is the output of our linear regression. We see R square as 95. This means that 95% of the variation in income is being explained by our age variable, and that is very good. We also check if the results are statistically significant or not, and we can check this by looking at the p-value. P-value is less than 0.05. This means that we have to reject the null hypothesis, and the alternate hypothesis is good, and we can say that yes, age is a determining factor when it comes to predicting the salary. All right, so that was the model that we have created, and we did it on the training data. So now let us look for the test data. So for the test data, it will remain the same. The code will remain the same. Just we need to change from X train to Y test. Okay. So I'm just copy pasting the same code here. So this will be X test intercept sm dot. We'll add the constant to this test also. Okay, and then we already have this model created. We will just use model dot predict, and what we want to predict, x test with intercept. Okay, and this will give our y predicted values. Okay, we just run this, and now let us look at the y predicted. Okay, this is an array format, but what are the true values? Y test is our true values. So now let us compare these two. Let me create a data frame here, pd dot data frame, and we can pass a dictionary here. Okay, we need two things. So what are the actual values and what are the predicted by model? Okay, the actual values are my y test. Okay, and the predicted values are my y spread. Okay, so this is a data frame. Let me save this into a data frame and let us look at the data frame. Okay, so there is this actual value and this predicted value. So obviously we see there is some deviation, and that is where we need to find the accuracy of the model, right? So there is a very common metric that we use is the mean absolute error. We also use the mean squared error when there is outliers. There's a lot of outliers, but I think our data set is not having any outliers, so we can use the mean absolute error. So from the sklearn metrics, we already have downloaded the mean absolute error metrics. So let us check mean absolute error will be my y test with y spread. Okay, so you can see the mean absolute error is 4072, which only states that if I'm giving a predicted value, then my result will be plus minus 4072. So which is okay. Then the next thing is we can also visualize the data, how our points are scattered across the line of best fit. And it is a very good measure, and it will tell us visually whether how close our predicted model is, how far it is from the actual values. So we can do this in the training data set, and we can also do that in the test data set. So we can visualize for the training set, and this can be a little bit of a fun exercise. So let us do it. So PLT. So we already uh, did the scatter plot, but then it was for the entire data set. We'll look at just the training data set. So PLT dot scatter. What we will do is just put the train and y train. Okay, PLT dot scatter, and I'll just, you can see this here, and I'll just put the color of this as red. Okay, so you can see these red points. But what is my line? I want to plot this line, right? My model line. So my model line will be what is my x train and what is my predicted y train values, right? So now in the next plot, I need to use this model and get the predicted y train values. So I'll just copy this here. So we already have the same x train, we already have the same age, but here will be my model dot predict. Okay, and what x values I will, what values I'll give here is the, by adding the intercept, right? We have to add the, so x train intercept. Okay, and this, let me put this color as blue. Okay, so I'll not do a scatter, let me do a line. So for line, I'll use a plot. Okay, so when we plot these actual values, we get these red dots. And when we draw this model, that based on my training data set, what should be my predicted y values, we get a line. And we can see all these points are closely hugging the model. And we can do similar visualization for my trained data also, just to see if it is overfitting the model or not. So here we see what is my x test value, and here what is my y test value, and then based on x test, what is the model predicting for my x test. Okay, so you can see, yeah, it is a little bit far off, but still it's close, right? So that was a quick visualization using the graphs. I hope you found this helpful, and all your concepts related to linear regression are clear now. Thanks.